Assalamu alaikum. Further to the two lessons from particle physics that we had covered earlier. In this lesson, we are going to discuss some past paper questions from particle physics. And if you had already seen those two lessons, I'm sure by the end of this lesson, you yourself would agree that the questions from nuclear physics are nothing less than a piece of cake. It's almost like Cambridge making up for hurting you in waves and superposition and DC circuits and electricity. So let's get started, hoping that by the end of the lesson, we'd be more confident in our understanding of particle physics. The very first question that we have from May June 24 says nuclei of an isotope of copper each have 29 protons and 39 neutrons. This is a beta negative emitter. State the nuclide notation in the form this for nucleus of copper. So if it is copper, number of protons are mentioned to be 29. Number of nucleons have to be proton plus neutron. That is 29 plus 37, which is 66. Then the energy spectrum of beta negative radiation emitted by sample of this isotope of copper is shown in this figure. It is very obvious from the figure that the energy range for beta particle is continuous. That is something we have already agreed upon. Now they are saying that use this figure to explain why other particle apart from beta negative particle must be emitted during this decay. Now पहले तो let's just establish what would be the other particle that would have emitted along with this beta negative. From our understanding, we already know that with beta negative, always an electron antineutrino would have been emitted. And the reason was beta has a continuous range of energy. However, decay में तो जो energy emit out होती है, it has to be constant, right? So the other particle, which in this case is antineutrino, it is going to have that difference of energy, right? So you can mention that the energy of decay is constant since beta has varying energy, and you can support it further by mentioning that the above figure shows that it has a continuous spectrum. Another particle having remaining energy or the difference of energy must have been emitted. Then, right next to this description, they are asking you to state the name of other particle emitted during the decay of this isotope. And it is none other than antineutrino. Then they are saying that the copper isotope decays to an isotope of zinc. Give the radioactive decay equation for this decay and include the nucleon and proton numbers of all the particles. What we had was copper decaying into zinc with the emission of beta negative, and in order to compensate for the energy we had antineutrino. Did they mention the emission of energy or did they specifically mention कि कोई energy emit नहीं हो रही? अगर इन्होंने mention नहीं किया है, so we'll simply mention energy as well. As for the proton and nucleon number, we had 29 and 66 here, right? It has 0, -1. This must be 30 to make up for the -1. We have 66 here, it is 0, 0, so this must also be 66. Okay, so this was as simple. The next we have is from May June 24, variant 22. It says a particle Q and a particle R. They are each composed of one quark and one antiquark. Now, as soon as we have seen एक quark और एक antiquark, आपको click करना चाहिए that they are speaking about hadrons. And hadrons, maybe they are not speaking about baryons, they are speaking about mesons. Q has, okay, so they are asking state the name of the class group of particle that includes Q and R. That is precisely what they are asking. They belong to mesons. Q has a charge of -1e, where E is the elementary charge, and R has a charge of 0. Now complete this table and show the possible second quark in each. For R, they've mentioned one quark. दूसरा आपसे पूछने बताएं क्या होगा. And for Q as well, they've mentioned one quark and they are asking कि बताएं दूसरा क्या होगा. In order to answer this question, first we have to be very clear and it should be on our fingertips. What is the charge of different flavors of quarks? So let me write it here. We have up, down, charm, strange, top, and bottom. We had plus 2 by 3e for up, charm, and top, and we had minus 1 by 3e for down, for strange, and for bottom, right? And जो इनके anti quarks हैं उनका exact इनका opposite है, right? So strange has minus 1 by 3e, and if the final charge जो हमारे पास है it is given to be minus 1 by e, so the remaining should have been it has to be minus 2 by 3. Why? So that minus 2 by 3 paired with minus 1 by 3 e gives us minus 3 by 3 e, which is nothing minus 1 e, right? So you are going to just write this here. And then when it comes to r, it has zero charge. Anti-up has charge plus 2 by 3e. So the second charge should have exact opposite value. It has to be minus 2 by 3e, right? यहाँ पर मुझे सिर्फ ये लिखना है. Now, just be very careful about what is the examiner asking you to do. The examiner is asking you to write the name of second quark. They haven't asked you to write the charge for second quark. आठ मिनट के करीब है ना कहीं. First, we have to be very clear with the charges of quark, right? We have up quark, down quark, we have charm, strange, top, and then bottom. Up having plus 2 by 3e. The same is the case with charm and top. The remaining have minus 1 by 3e, right? Minus 1 by 3e, minus 1 by 3e. Then their entire quarks have the exact opposite, minus 2 by 3e plus 1 by 3e, minus 2 by 3e plus 1 by 3e minus 2 by 3e and then plus 1 by 3e. This is for anti-up, anti-down, anti-charm, anti-strange, anti-top, and anti-bottom. Now we are good to go with this question right here. They are saying that Q has a charge of minus 1 by E, and since it is a meson, it is made up of a quark and a anti-quark. Quark they have mentioned, it is a strange. कह रहे हैं जो दूसरा quark है ना वो आप इधर मुझे mention करके बताएं. Strange we know already has a charge of minus 1 by 3e, and we know कि दूसरे का charge मिलने के बाद answer should be minus 1e. What should be the value here? It should be minus 2 by 3e, so that it gives you minus 3e over 3, which is nothing but 1 by e, right? Now, who does this charge belong to? Minus 2 by 3. It belongs to anti-up, anti-charm, and anti-top. So you are going to write it here, Tino, or any one of them. And anti-top, right? You have to write the name, you don't have to write the charge here, right? And then the next we have is for R, they've mentioned कि उसका final charge 0 है. It is made up of one anti-up. Anti-up has a charge of minus 2 by 3e. And for the final charge to be 0, the second quark should have the charge of plus 2 by 3e. Now, who does this plus 2 by 3e belong to? It can belong to up, charm, or top. So you'd write up, charm, or top. So done with this 2 marker. The next we have is, okay, so they have given us question from for 3 marks. I hope this isn't the case for 2026. Then in another question, they are saying that nuclei of an isotope of samarium each contains 62 protons and 85 neutrons. Now state the nuclide notation in the form A and Z. So the symbol is given, proton number, they are mentioned to be 62. As for neutron number, they are 85. So nucleon should be 85 plus 62. You can write whatever is the sum yahan par, right? This makes up for our 1 mark. Let's be very efficient and start marking ourselves. This isotope of samarium is radioactive and it decays by emitting particles. Gamma radiation is not emitted. The energy spectrum of the emitted particles is shown here. Number of particles, multiple particles having this energy, a fixed value of energy, they are emitted. Explain how this figure shows that this isotope of samarium emits alpha particles and does not emit beta particles. Now, using the figure, how can you show it? It has to be alpha particle. Why? Because the figure shows discrete energy, and alpha has discrete energy and beta has continuous spectrum. You have to write it for 2 marks. 1 mark where you have to mention that this graph has discrete energy, it belongs to alpha, and the other to mention why it is not beta, because beta has continuous spectrum. So you would mention that the emitted particle has discrete energy like alpha particle. However, or whereas beta particles have a continuous spectrum. This should do for 2 marks. Then this isotope of samarium decays to an isotope of neodymium. Give the radioactive decay equation for this decay. Include the nucleons and proton numbers of all the particles. We had samarium, then we have neodymium, and we have an emitted alpha particle which is 2 and 4, and they've said कि उसके अलावा और कुछ emit out नहीं हो रहा, right? Let's mention the values which I clearly have forgotten. The proton number was 62. The nucleon, after adding them, turned out to be 142. And since we have alpha here, so conservation of charges suggests that it has to be 60. And since we have 4 here, again the conservation suggests that it has to be 143. Then a baryon is composed of 3 quarks which all have different flavors. Okay, so they are restricting us in baryons as well, because इससे पहले जो हमने protons and neutrons के बारे में पढ़ा था, they did not have to have different flavors, right? Proton was made up of 2 up and 1 down, so there was a repetition of one flavor. And the same was the case with neutron as well. It was made up of 1 up and 2 down. But यहाँ पे they have limited us to a baryon. That means it is made up of 3 quarks, but flavors are not repeating. The baryon has a charge of 0. That is, the sum of the charges of 3 quarks should give us 0. 2 of the quarks in the baryons are 1 up quark and 1 bottom quark. जो तीसरा चार्ज है उसके लिए कह रहे हैं कि आप मुझे वैल्यू बताएं. They've said 1 up quark. Up quark has a value of plus 2 by 3 elementary charge. Then we have bottom. Bottom has a value of minus 1 by 3 elementary charge. And they've said कि जो हमारे पास resultant है इसका charge is 0. What should be the value here? Plus 2 by 3 minus 1 by 3. In order to get final 0, it has to be minus 1 by 3e here. So minus 1 by 3e, what did we agree? किस किस से belong करता है? It belongs to down, then strange, and then bottom. And now that they've already mentioned कि एक तो इसमें bottom already है, and ऊपर they've told us कि they have different flavors. So इसका मतलब है this makes us conclude that bottom cannot be of our option, right? We have to go with down or strange. That is what we are going to write here. It is either down or strange, and the charge we have agreed has to be minus 1 by 3. The next they are saying potassium 40 undergoes beta negative decay to form a nuclide of element X. Particle Z is emitted during the decay, like potassium decay हुआ, we have got beta, साथ में particle Z, and अब जो daughter nuclei है, it is X as well. Now they are asking us to state the value of P, Q, R and S. जो मेरे और आपके जहन में पहली बात आती है, it would have been how is it possible कि मेरे पास दोनों unknowns हैं right side पे. It's like how can I equate it? And the same is the case with masses as well. But if you are well versed in beta decay, you would have known that every time beta negative is emitted, antineutrino emits, and that Z is exactly the antineutrino. It has 0 charge, it has 0 mass. Beta itself, we know that because it is negative, so this S must be minus 1 and this R must be 0. Now we can easily equate the equation to know what does this Q equal to and what does this P equals. 19, here we have 0, here we have minus 1, so it has to be 20. 40, here we have 0, here we have 0, so it has to be 40. This is what we are supposed to write. Then state the name of particle Z. The particle Z is none other than antineutrino because it is beta negative, right? Then state the name of the class of fundamental particles to which both beta negative particle and particle Z, which is antineutrino, they belong. Who do you think they belong to? They belong to leptons. Determine the quark composition of an alpha particle. Okay, seems like something we haven't discussed earlier, but let's get into it. What is alpha particle composed of? It's composed of two protons and two neutrons. Did we discuss the quark composition for proton? It was two up and one down. That means for two protons, we have four ups and two downs. Then, when it comes to neutrons, we had agreed that one neutron is made up of one up and two down, which means that two neutrons are made up of two ups and four downs. And this makes us conclude that an alpha particle, in terms of quark composition, has 4 plus 2, 6 up quarks, 2 plus 4, 6 down quarks. Compare an alpha particle with a beta plus particle in terms of their masses and charges. Alpha has plus 2e charge, whereas beta positive has plus 1e charge. So you can say that alpha particle has double the charge as compared to beta positive. And when it comes to their masses, you can simply mention that the mass of alpha particle is much greater than the mass of beta particle. Because we have agreed that almost 2000 beta particles would come together to make the mass of one nucleon, and alpha particle has four nucleons, so we can say 4 times 2000 mass of electron gives us the mass of alpha particle, and that is something you do not need to write. This is just for your understanding. They've asked you to just compare it, so you can just go away with saying that the mass of alpha particle is much greater than the mass of beta particle. The next we have is, this looks like O level wala question. Nucleus P undergoes alpha decay to form nucleus Q. Like we had P, it decayed to form Q, and then we had साथ में एक alpha particle. Nucleus Q then undergoes further decay to form nucleus R. The proton and nucleon number of P and R are shown. P has 84 protons and it has 216 nucleons. Q they haven't provided us with, but it is not that difficult, honestly, to find out what would be the charge number and mass number of Q, since it was 84, दो alpha particle के पास गए, remaining 82 यहाँ पर होने चाहिए. 216, 4 nucleons for alpha particle, remaining 212 should have been here. इसी तरह Q, now that we know it is 82 and 212, R, it is obvious from this figure. It is 83 and then we have 212. What did they ask us to do? Like to find the composition of Q, that's it. They are asking to draw a cross to show the proton number and nucleon number of Q and then state the name of particle emitted as Q decays to R. Q की तो composition we have already agreed upon, so let's just simply mark it here. We have agreed that Q is 82 and 212. We have 82 here and then 212. It has to be here. And then when it comes to R, what additional particle would have emitted? 82, 81. So the other particle, let's label it Y, should have -1 here. 212, 212. It should have been 0. So now that we have known it is -1 and 0, we can directly label it as beta particle. It is beta negative. And the moment we have seen it is beta negative here, we have to write an electron antineutrino as well. State the names of particles. See how smart they are. It's beta negative and electron antineutrino. Then before the alpha decay, P is traveling at a constant velocity. After the decay, Q has a velocity of 1.3 exponent 5 meters per second at an angle of 68 degree to the original path of P. The alpha particle has a velocity 150 exponent 5 at an angle of theta. And then what do we do? Okay, use the principle of conservation of momentum to determine Q. That Q is what we have to ask. So they have combined the vectors with the nuclear physics, the particle physics. Seems like Cambridge was offended with my comment on particle physics being a piece of cake. Let's just do this. Okay, so we have to find theta. The particle P was traveling along x-axis. This makes us conclude that the y component of its momentum before the collision was 0. And hence, for the conservation of momentum, the y component of its momentum after the collision should also be 0. That means y component of alpha's momentum plus y component of q's momentum should give us 0. Or we can also say opposite है ना, या तो मैं इधर माइनस लगा दूं या फिर मैं ये कह सकती हूँ कि they should be equal and opposite. Clear? Now we are talking about momentum, so it's nothing but the product of mass and velocity, right? So I should be write m y component for this alpha. Here I should be writing mass of q times velocity, y component of velocity of this q. Then, do we know mass of alpha particle? Did they provide us with one and the mass of q as well? Okay, they didn't provide us with the mass of these particles, but so far we know that q had 212 nucleons, right? So its mass should be the mass of nucleon multiplied with 212. So I can directly write in terms of atomic mass unit, it should be 212 U. Mass of alpha, alpha is made up of 4 nucleons, so I can write 4U instead. Then we have y component of alpha ki velocity. And then y component of q ki velocity. Q we have right here. So its y component should be this. Since we have an angle here, it is hypotenuse. This right here would be perpendicular and this would be the base. If I have to write this, knowing the resultant, which is the hypotenuse here, I can use sine. So we know कि q की velocity is 1.3 exponent 5. इसका y component would be this times sine 68. Then, okay, so I wrote q की velocity instead of writing alpha की velocity. So let me rewrite it here. Mass of alpha particle. यहाँ पे we have mass of q times y component of velocity of q, which is 1.3 exponent 5 sine 68. And when it comes to alpha key velocity or y component, it was 1.5. Okay, so it is 1.3 exponent 5. Okay, it is 150 exponent 5, my bad. We have 150 exponent 5 sine theta. This theta is what we have to find. So is there anything else in this equation that is unknown? You can get cancelled since we have multiplications on both sides. So we can find theta as sine inverse of 212 into 1.3 exponent 5 into sine 68 over this 150 exponent 5. I hope this makes sense to you. This was nothing but the simple rearranging of the equation. Let's put these values in the calculator and see what do we have. Okay, so I've got 25 degrees. That is the value of theta. Then they are asking us to calculate the kinetic energy of alpha particle. So kinetic energy should have been half mv square. Velocity they had already provided us. For alpha it was 150 10 raised to the power 5. So let's square the velocity. Half as it is. How about mass? This time we cannot write for u because u, remember, was a relative mass for our understanding. We have to write alpha has 4 nucleons. So 4 multiplied by mass of each nucleon, which is this 1.66 exponent minus 27 kgs. And that is something which would be given as a constant in your paper. So you need not to worry. You can have it from your paper and you'll just have to multiply these values and you'll get your final answer in terms of joules, which mine turns out to be 7.5 10 raised to the power minus 13 joules. I think that's enough from particle physics. Attempt the past paper questions at your end and see if you are able to get the answer for these questions and if you have any concerns unanswered. So till the next video, Allah Hafiz.